First of all, apologies for delay. I really tried hard, but well, things happen. So today's topic is surface-mounted devices. This presentation is for those who have no idea what are surface-mount devices, maybe heard about it, but have never worked, have never seen it. So this is a gentle introduction to SMD devices. So first of all, everybody says SMD is hard. The devices are small, tiny, you cannot see it, you cannot grab it, you cannot solder it. That's not true. That's a pretty common misconception that arose from the fact that SMD technology actually is completely different than through-hole technology. If you try to work with SMD devices like you used to work with through-hole components, that's what will happen. That's the idea that you will get, that it's impossible to work. So I will talk about working with SMD devices during the second presentation, but right now I would like to introduce the SMD devices, what it is. This is for those who have no idea what it is. So yeah, it's true that SMD devices are small, but not all of them. Actually, there are many through-hole components which are even smaller. You have big SMD resistors, you have big SMD capacitors, inductors can be even bigger. So it's not true that they are tiny. Just you have to learn how to work with them. Unfortunately, your gas-powered soldering iron will not work with this. You will have to invest in a better soldering iron, but you should have done it anyway long time ago.
Yeah.
So, sorry. So, well, as I said, SMD is completely different way of working with devices. You can, of course, solder each pin separately, but if you have like 100-pin integrated circuit, have fun. And this is the best way to actually start to hate SMD devices, not to work with them. What you should get, besides of good soldering iron, and I really recommend it, is a hot air station. This really helps. What is hot air station? This is pretty much not that big, a small fan which blows hot air. So it's like your wife's hair dryer, but a little bit stronger. And unfortunately, heater paint stripper will not work. It doesn't have, you don't have control over the airflow, you don't have control over the temperature, and this is unfortunately necessary to work with SMD devices. You can use a paint stripper to the solder board. Yeah, it works pretty well, but not for soldering. So forget about it. So, what are the biggest problems people have with SMD devices? Parts are small, as I said, not all of them. Some, yes, they are small. It's almost, for example, if you take 0201 component, you cannot see it. It's so tiny that it's like a grain of sand. But you don't have to work with such tiny components. There are many components which are much bigger and very convenient to work. Me, myself, I really like 0805 components. They are pretty big enough to handle them by hand, and small enough to pretty much fit anything you want on the board. So you don't have patience to solder on those pins, so don't solder them separately. Use other techniques. You cannot plug SMD part into a breadboard. Well, that's true, but you have there are many adapter boards. You can solder the device on the board, solder pins, and you can use it on the breadboard. So it's actually a small problem. You can reuse this. You can use these devices many times in different designs. So it's just a tiny annoyance, not a problem. So, yeah, some people will say, don't use breadboards in devices. Yeah, I had used it for a long time. No, don't use it. Make a piece, you can order very cheaply a printed board. It costs like $10 for 10 5x5 centimeter boards. It's pretty much peanuts. If you don't want to wait a long time, make a board at home. It takes about half an hour to spin a board, really. It's not that long. You can use universal proto boards. 08, 05, 06, 04 components fit very well on standard proto board. So you can use it. So, but why you should bother with it? Well, first of all, parts are getting smaller. Most of the interesting chips, most of the interesting components are available only in surface mount packages. If you want to use modern ARM microcontroller, there are only about, I know only about a couple of chips in deep packages. The rest are all surface mount packages. Surface mount components are much smaller. You can design much smaller, much denser board. And also, for surface mount devices, you don't need to make holes. So you don't waste space on the holes, on the pads, on both sides of the board. You can use this space to place more components or for interconnects. So for me, it's a no-brainer. I was really scared of SMD devices until I tried it. Right now, when I design a circuit, I don't even think about through-hole components. Unless I cannot get something in SMD format or it is impractical, I use always surface mount components. Okay, but we are radio operators. What about us? Well, this is actual schematic of a resistor. What you know is this part. What is actually all these components? So you have capacitance between the leads, you have inductance of the leads, and for through-hole components, especially this inductance can be very big. So you design, let's say, circuit which is supposed to work at 70 centimeters, and suddenly you find out that it doesn't work as you thought it would work. You measure all the components, everything is fine, but it doesn't work because of the parasitic components. If you use surface mount devices, well, first of all, the components are smaller, so the capacitance will be smaller, but you have no leads, or the leads are much shorter. So the parasitic inductance is much smaller. That's why it is important. How important it is? This is table taken from application note of amplifier, MMIC, and this is what the manufacturer advises as an inductance to deliver power to the part. So you have 3 leads, one is input, one is ground, one is output, and the power is delivered to the output. You have to couple the DC power with an inductor. And these are recommendations for this inductor which delivers the power. What we have for small frequencies, 08, 05 devices. For higher frequencies, 08 or 05 is too big. You should use 06 or 03. So you see that this is a big problem, and you will find it even in recommendations from manufacturers. And don't even think about using through-hole components. It will not work. So how do those devices look? Well, these are the most common forms of devices that you will find in circuits. So these are resistors, capacitors. They look very similar. This is polarized capacitor, so you have one side is marked. If this is tantalum capacitor, it will be different color. This is diode. Usually you have, this is also very similar to capacitor, but much smaller. Yes?
Oh, are the resistors color coded?
No, on resistors usually you have the value printed on as numbers. Well, this is encoded, but it's very easy to read. So for example, 10K would be 103. That means that this is 10 times 10 to the power 3. However, not all the components and not all the resistors have the value printed on, so don't mix your parts, keep them separate. You will appreciate it. Capacitors, on the other hand, only electrolytic capacitors, only tantalum capacitors have values printed on. Also, this is encoded, but the exponent is, you have to put minus in front of the exponent. So 1003 would be 10, and 1006 would be 10 times 10 to the minus 6. It's easy to figure out. But small, cheap capacitors, then they don't have any markings. So if you mix them, you have to measure. There's no other way to distinguish them. So keep everything separated. The parts are delivered in tapes. Keep it in tape, or throw it into a container, a locked container, where it will be safer. You don't lose it when you don't mix them. Because if you mix, you will have a problem. With semiconductors, it's a little bit better. Transistor diodes, they are marked with codes. However, to find out what device it actually is, sometimes it's almost impossible. So you will have, for example, 3K. That's it. And you have to find out what this 3K means. There are big tables of the markings on the components, and you will see that 3K is either this diode or this transistor or this transistor. That's it. Transistors, this is the most common SOT package. Of course, there are other packages, but these are just the most common, and small outline integrated circuit. Again, there are many other packages, but well, when you will see it, you will know. One trap that you have to be aware of, not to fall in, is that world is metric. US is the only industrialized country which uses imperial system, and everybody else uses metric system. So right now, the sizes of cheap resistors or cheap capacitors are still quite often given in imperial units. However, it's more common that you will see size in metric units. And it's very easy to confuse them. So these are metric codes. And by the way, these are two, you should read it as two numbers. This is width, and this is length, this is width. So for example, 6332 means that this is 63 tenths of millimeter this way, 32 tenths of millimeter this way. These are codes for imperial sizes. Again, two numbers, but this is in thousandths of an inch. So this component, the same component, has in imperial code 2512. This means that this is 25 thousandths of an inch this way, 12 thousandths of an inch this way. It's very easy to confuse if you don't see that component, because you see, these are identical. These are very similar. So you have to know which one it is, and it's becoming more common that the manufacturers don't even bother to give the size in imperial units. I was looking for an example for the presentation, and the first part that I found had actually markings size only in millimeters. It didn't have even the size. I'm not talking about the package size. Just even the dimensions were only given in millimeters. So get used to metric system. Okay, so that's all for the introduction. Are there any questions for this part? Yes?
What's a good method of securing them to the board, like an adhesive, so they don't flop around when you're trying to attach them?
I use resin. I just coat the board with resin flux and just place the components. I will talk about it during the second part of the presentation. You had a question, right? Yes?
So when you talk about the blowing device, the heated air device in your presentation?
Yes. And I'm also planning to do a short presentation, practical presentation, so you will see how